Hello, it's Jane Liu from the University of New South Wales in Australia. Here, I would like to share with you our work, Nephalai, towards LPWAN CRAN with physical layer compression. In this paper, we propose a compressive sensing-based cloud radio access network to reduce uplink bitrate of the physical layer between the gateways and the cloud server for multi-channel LPWANs. In this research, we mainly focus on LoRaWAN. First of all, let's have a look at the system. Here is an overview of the traditional LoRaWAN network. The signal sent from end devices will be modulated and decoded in the gateways and then be forwarded to the cloud for further processing. While for CRAN, we move the demodulation and decoding up to the cloud. Now the gateways only need to compress the signal, and the compressed signal will be forwarded to the cloud for reconstruction, demodulation, decoding, and processing. For the gateways, a specific hardware is no longer necessary, as any general radio receiver can contribute to this network. One possible implementation is with software-defined radio, or SDR. Inside a gateway, our SDR samples are wideband, and then each subchannel is extracted with frequency conversion, low-pass filtering, and decimation. If a channel is active, the physical layer will be compressed and uploaded to the cloud for further processing. Now you may have the question, why CRAN and why compression? For the first question, CRAN can provide network capacity for more than 8 channels, while the commercial gateway can currently only support 8 channels. It also provides the flexibility to involve the community to help quickly deploy the infrastructure, because any low-cost radio receiver instead of a specific hardware is acceptable. For example, a TV antenna or RTL SDR, which is worth only $10, can be used. Besides, CRAN can provide extra benefit, such as spatial diversity for signal strength improvement. Then the second question, why compression? Because such CRAN can generate a huge bandwidth for the offloading network. You may choose to use the optic fiber, but the cost for such data rate may not be acceptable, especially for low-cost IoT applications. And such bandwidth is beyond most home internet, which may limit the vision for community involvement. The community may not be happy if the CRAN consumes too much of their bandwidth. As we cannot discuss every detail in a short video, here I only focus on compression. We choose compressive sensing as a compression technique, which is simple and efficient. If we look deeply into the signal, we'll find that signal is actually very sparse. For the demodulation process, we first multiply the raw symbol in figure A with a downchirp, and then get a flat symbol in time frequency domain as shown in figure C. And then we apply DFT or FFT on the flat symbol. We'll see the frequency domain, which is very sparse, as shown here in figure E. Now, let's reverse the demodulation procedure. Starting from the sparse frequency domain, we can obtain the dictionary psi by the inversed downchirp matrix multiplied by the inversed DFT matrix. Even the signal is not detected or aligned in advance, as shown in figure B, the signal is still sparse, as shown down there in figure F. Here we can obtain a general sparse dictionary without simple alignment in advance, which means that the heavy duty of detection and calibration is not required by the gateways and can be moved up to the cloud. We implemented the prototype with SDR and beta systems. We evaluate the performance in our campus. With a single gateway, we found that the compression ratio is affected by the spreading factor of LoRa and the signal-to-noise ratio, which means that you can define a suitable compression ratio based on these two factors to maintain the packet reception rate without the system downgrading. With 4 gateways, we prove that even compressed signals can improve the performance with multiple gateways compared to only 1 gateway. The case study achieves 70% improvement of battery life for the transmitter. Thanks for watching. Hope our work can help the community towards building up a hybrid LPWAN CRAN community network. Thank you.